Hello dear students, today we are going to see serial communication. Now 8051 microcontroller is parallel device that transfers 8 bit of data simultaneously over 8 data lines to parallel IO devices. Parallel data transfer over a long range is very expensive. Hence, a serial communication is widely used in long distance communication. In serial data communication, 8-bit data is converted to serial bits using a parallel in serial out shift register, and then it is transmitted over a single data line. The data type is always transmitted with least significant bits first. Now, the basics of serial data communication. First of all, we have serial transfer. That is, we have a sender, that is a transmitter, and a receiver. It is also known as simplex transmission. In this serial transfer or simplex transmission, the line is dedicated for transmission only. The transmitter sends and the receiver receives the data. One way ही होता है, सिर्फ transmit ही होगा. Then there is a parallel transfer where the sender can send the data and the receiver can receive the data. But in both the cases, serial में एक ही device कर पाएगा एक time पर, parallel में parallelly many devices can transmit data at the same time. So, but there will be only transmission of data, they cannot receive data. दोनों काम नहीं कर सकते कि transmit भी कर रहे हैं और receive भी कर रहे हैं. So they can do only the transmission of data. Hence it is also known as simplex transmission. That is the first type of serial communication. उसमें ट्रांसमिट होता है डेटा और रिसीवर एंड पे रिसीव होता है. अगर रिसीवर कुछ सेंड करना चाहे तो वो सेंड भी नहीं कर सकता, एट द सेम टाइम ट्रांसमीटर एंड पर उसको रिसीव भी नहीं किया जा सकता. द सेकेंड टाइप इज हाफ डुप्लेक्स communication link. In half duplex, the communication link can be used for either transmission or reception. The data is transmitted in only one direction at a time. For example, अगर transmitter जो है ये यूज़र यहाँ से ट्रांसमिट कर रहा है डेटा, तो एट अ टाइम डेटा ट्रांसमिट होगा और यहाँ पर रिसीव होगा. उसी समय पर यहाँ से ट्रांसमिट हुआ डेटा इधर रिसीव नहीं हो सकता, एट द सेम टाइम नहीं हो सकता. जैसे ही पहले का ट्रांसमिशन खत्म हो और रिसीवर एंड पर रिसीव हो, इनका टास्क खत्म होने के बाद यहाँ से जो भी डेटा है वो वेटिंग में रहेगा, ट्रांसमिट होगा और फिर रिसीव होगा. दोनों एक साथ ट्रांसमिशन और रिसेप्शन काम नहीं कर सकते. हेंस इट इज नोन एज हाफ डुप्लेक्स. देन फुल डुप्लेक्स कम्युनिकेशन लिंक. इफ द डेटा इज ट्रांसमिटेड इन both ways at the same time, it is full duplex. That is, transmission and reception can proceed simultaneously. This communication link requires two wires for data, one for transmission and one for reception. दोनों at a time हो सकते हैं, transmit भी कर रहा है और receive भी कर रहा है data. Then it is full duplex communication. Then moving towards reception and transmission pins in 8051. To establish communication between a controller and the PC, we must use serial input output protocol, that is RS232, जो हमने पहले पिछले लेक्चर में देखा है पूरा इसका डिस्क्रिप्शन. बट ये यूज करके वी कैन गो फॉर सीरियल IO communication, which was widely used in PC and several devices. PC works on RS232 standards, which operates at a logic level of minus 25 volts to plus 25 volts. But microcontrollers use TTL logic, transistor logic, which works on 0 to 5 volt, and it is not compatible with RS232 voltage levels. So MAX232 is a specialized IC which offers intermediate link between microcontroller and the PC. The transmitter of IC will convert the TTL input level to RS-232 voltage standards. Meanwhile, the receiver of this IC will convert RS-232 input to 5 volt TTL logic levels. Then the other SCON register that is used, we are going to see this in detail. ये जो आपको diagram दिख रहा है, we'll see it in detail. This is how the interfacing takes place. The microcontroller cannot be directly connected to RS-232. There's an intermediate MAX232 which converts the voltage level to 0 to 5 volts, or it converts it to the level of minus 25 volt to plus 25 volt for proper communication between a transmitter and RS-232 connector. The microcontroller has an inbuilt UART for carrying out serial communication. The serial communication is done in asynchronous mode. A serial port, like other PC ports, is physical interface to establish data transfer between the computer and external hardware devices. इसके आगे जो भी हम hardware device connect करेंगे वो. This transfer through serial port takes place bit by bit. IBM introduced RS-232 version of serial I/O standard, which is most widely used in PCs and several devices. The range minus 3 volt to plus 3 volt is undefined. The TTL standards came along time after the RS-232 standard was set. Due to this reason, the RS-232 voltage levels are not compatible with the TTL logic. Therefore, while connecting an RS-232 to microcontroller system, a voltage converter is required. This converter converts the microcontroller output level to RS-232 voltage level and vice versa also, for this also. In the IC MAX232, also known as line driver, is very commonly used for this purpose. The simplest connection between a PC and microcontroller requires minimum of 3 pins. One for the reception, that is the receiver pin, the ये वाली RXD, then the transmitter pin, that is TXD, and the ground pin of serial port. Then the pin for reception is connected to the pin of transmission, like this here. ये जो reception की pin है और ये जो transmission की pin है, ये T1 और R1 के साथ में connect करते हैं for MAX232. MAX232 has two set of line drivers for transferring and receiving the data. The line drivers used for transmission are called T1 and T2 also, whereas the line drivers for receiver are designated as R1 and R2 या फिर RN and ROut भी बोलते हैं. The connection of MAX232 with computer and controller is shown in the circuit diagram. An important parameter that is considered while interfacing serial port is the baud rate. Baud rate क्या होता है? It is the speed at which data is transmitted serially. It is defined as number of bits transmitted or received per second. It is generally expressed in bits per second. The 8051 microcontroller can be set to transfer and receive serial data at different baud rates using the software instructions. Then SCON, that is Serial Control Register, जो मैंने आपको बोला था ऊपर, अब हम यहाँ डिटेल में देखेंगे. What is SCON now? It is a bit addressable register used to set the mode in which serial communication takes place in the controller. The figure shown here gives the configuration of SCON register, the complete configuration. सबके पिन के बारे में भी यहाँ पर बताया हुआ है. That is SM0, SM1. These are serial mode control bits. Okay, serial mode control bits. SM2 is multiprocessor mode control bit. That is logic 1 enables multiprocessor mode and 0 for the normal mode. Then REN, that enables serial reception Serial reception, that is if it is set, it enables the reception, otherwise the reception is disabled. Then TB8, it is the ninth bit of the data that is to be transmitted. RB8, it is used in mode 2 and 3. It is the ninth bit received by the microcontroller, but these two are not widely used. T1, it is known as transmit interrupt flag, which is set by hardware to indicate the end of transmission. It has to be cleared by the software. R1, R1, it is known as receive interrupt flag. Receive interrupt flag is which is set by hardware to indicate the end of reception. End of reception मतलब वहाँ पर डेटा खत्म हो गया है. It has to be cleared by the software itself. These two bits of SCON register, that is SM0, SM1, determine the framing of data. Like 00 है तो serial mode 0, 01 है तो serial mode 1, 10 है तो serial mode 2, 11 है तो serial mode 3. By doing this, the number of bits per character and start and stop bits are recognized. There are total 4 modes only. Then REN, T1, R1 जो अभी हमने देखा are also referred as SCON 4. When it is high, it allows 8051 to receive data on the reception pin. So to receive and transfer the data, REN, that is receive enable, must be set to 1. When REN is 0, the receiver is disabled. It is achieved by the instructions set B SCON 0.4 and also by clear SCON 0.4. सेट करना और उसको क्लियर करना. So ये instructions use होती है उसमें. Then T1 is the D1 bit of SCON register. When 8051 finishes the transfer of 8-bit character, it raises the T1 flag to indicate that it is ready to transfer another byte. The T1 bit is it is TI. The TI bit is raised at the beginning of stop bit. RI, receive interrupt, is the D0 bit of SCON register. When the 8051 receives data serially via RxD, that is the reception pin, it gets rid of start and stop bits and places the byte in the S buffer register, serial buffer register. Then it raises the RI flag bit to indicate that a byte has been received and should be picked up before it is lost. The RI is raised halfway through the soft stop bit क्योंकि वो तब तक stop होना चाहिए. Now talking about the interrupts, the most powerful and important feature are interrupts in 8051 microcontroller. In most of the real-time processes, to handle certain conditions properly, the action task must be halted for some time. It takes required action and then it must return to the main task. For executing such type of program, interrupts are necessary. It entirely differs from the polling method wherein the processor must check sequentially each device and ask whether the service is required or not while consuming more processor time. Interrupts are the events that temporarily suspend the main program, pass the control to external sources and execute their task. It then passes the control to main program where it had left off. 805 interrupts in 8051 microcontroller are more desirable to reduce regular status checking of interface devices or the inbuilt devices also. Interrupt is an event that temporarily suspends the main program. Then it passes the control to special code section, executes the event related to that function and resumes the main program flow where it had left it. Interrupts are of different types like software and hardware, maskable and non-maskable, then fixed and vector interrupts and many more. The interrupt service routine, that is ISR, comes into the picture when interrupt occurs and then tells the processor to take appropriate action for the interrupt. And after ISR execution, the controller jumps into the main program. Upon receiving the interrupt signal, the microcontroller first current instruction and saves the PC on stack. Then it jumps to a fixed location in memory depending on the type of interrupt. Then it starts to execute the interrupt service routine until RETI, that is return from interrupt, is raised high. Upon executing the return from interrupt, the microcontroller returns to place where it was interrupted. Get pop PC from the stack to find out its last location. Then interrupt sources. The 8051 microcontroller can recognize different events that cause main program to interrupt from the normal execution. These 5 sources of interrupts are timer 0 overflow interrupt, that is TF0, timer 1 overflow interrupt, that is TF1, external hardware interrupt, that is INT0, external hardware interrupt, that is INT1, serial communication interrupt, that is RI or TI. The enhanced version has 22 sources, more timers, programmable counter array, analog to digital converters, more external interrupts, UART, etc. The timer and serial interrupts are internally generated by microcontroller, whereas the external interrupts are generated by additional interfacing devices or switches that are externally connected to the microcontroller. These external interrupts can be edge triggered or level triggered. When an interrupt occurs, the microcontroller executes the interrupt service routine so that memory location corresponds to interrupt that enables it, like this. So each interrupt has a specific place in code memory where program execution begins, that is interrupt service routine begins. So these are the different places where the interrupt vectors are placed while execution. उनकी memory location जो है वो बताई हुई है यहाँ पर. You all can see it, that is external interrupt 003H. टाइमर के लिए उनके एड्रेसेस बताए हैं जहां पर वो प्लेस होते हैं. Interrupt enable register. All the interrupts can be set or cleared by some special function register, that is also known as interrupt enabled, that is IE, and it is totally dependent on priority, which is executed by using interrupt priority register. The interrupt enable, that is IE register, is used for enabling and disabling the interrupt. This is a bit addressable register in which EA value must be set to 1 for enabling the interrupt. The individual bits in this register enables the particular interrupt like timer, serial and external inputs. If we consider the IE register shown in figure, bit corresponds to 1 activate the interrupt and 0 disable the interrupt. Now EA, that is enable hai, so what it will do, it will give you the interrupt, so it disables everything else. If EA is 0, no interrupt will be acknowledged. If EA is 1, interrupt source is individually enabled or disabled by setting or clearing its enable bit. Then जो dash दिख रहा है, these are not implemented, they are reserved for future use. ES, or before that we'll see ET, enable or disable the timer 1 overflow interrupt. ES is enable or disable the serial port interrupt. Then ET1, EX1 ये होता है enable और disable timer 1 overflow interrupt या फिर अगर EX है तो एक्सटर्नल इंटरप्ट को एनेबल या डिसेबल करने के लिए. Similarly, ET0, EX0 is for timer 0, overflow interrupt and external interrupt 0. Here we have interrupt priorities. Uh, Interrupt priorities upon reset may be used. As 8051 interrupt priorities, the lowest priority interrupts are not served until the microcontroller is finished with high priority ones. In case when two or more interrupts arrive, microcontroller queues them according to the priority. That is using the interrupt priority register. The structure of interrupt priority register is something like this. Using the interrupt priority register, that is IP register, it is possible to change the priority levels of an interrupt by clearing or setting the individual bit in interrupt priority register, as you can see in the figure. It allows the low priority interrupt uh, can interrupt the high priority interrupt, but it prohibits the interruption by using another low priority interrupt. If the priorities of interrupt are not programmed, then microcontroller executes the instruction in a predefined manner, and its order is INT0, TF0, this one. INT0, TF0, INT1, TF1, then serial communication, that is RI and TI. इसमें डिफॉल्ट वे में वो उसको प्रायोरिटी देता है. The next is applications of microcontrollers. Now there are different applications. We'll start with the first one, that is simple interfacing example of stepper motor. This circuit consists of 8051 microcontroller, then inverting buffers, a stepper motor. 8051 is low power, high performance CMOS 8-bit microcontroller. It has 32 programmable I/O lines, input output lines. It has 4 kilobytes of flash programmable and erasable memory. An external crystal oscillator is connected to pin number 18 and 19 of the microcontroller. The motor is connected to port 2 of microcontroller through a driver IC. Driver IC जो ये inverting buffer वाला दिख रहा है आपको वो. This is a current driver IC. It is used to drive current of stepper motor as it requires more than 60 milliamperes of current. Stepper motor has 6 pins. In these 6 pins, 2 pins are connected to the supply of 12 volt and remaining are connected to output of stepper motor. Stepper motor rotates at a given step angle. Each step in rotation is a fraction of full cycle. This depends on mechanical parts and the driving method also. Similar to all the motors, stepper motors will have stator and rotor. Rotor has permanent magnet and stator has a coil. The basic stepper motor has 4 coils with 90 degrees rotation step, जो हमने पहले डायग्राम में पिछले लेक्चर्स में देखा है. These 4 coils are activated in cyclic order. The figure shows you the direction of rotation of shaft also. Arrow में दिखाया हुआ है. There are different methods to drive a stepper motor and there are several applications of this stepper motor also कि सिर्फ उसको घुमाया वो उतनी application नहीं है. This circuit can be used in robotic applications, in mechatronics applications, in disk drives, matrix printers, etc. बहुत सारी उसकी applications है. Then the second example is 7 segment interfacing. 7 segment display हमने देखा था, सबको पता ही है कि LED का 7 segment जो display रहता है, पर उसको interface कैसे करेंगे, तो जो diagram दिख रहा है उस तरीके से directly नहीं connect कर सकते, बीच में driver IC ज़रूरी रहती है. The circuit shown here has a controller, that is microcontroller. It is based to count 0 to 9, counter के जैसा काम करेगा. which has 7 segment LED display interfaced to it in order to display the count. The simple circuit illustrates two things: how to set up simple 0 to 9 up counter using 8051, and more importantly, how to interface a 7 segment LED display to 8051 in order to display a particular result. The common cathode 7 segment display, that is D1, is connected to port 1 of the microcontroller as shown in the figure. R3 to R10 are current limiting resistors that are present in this driver circuit. S3 is the reset switch, and they are related to the clock circuit. The software part of the project has to do some specific task. वो task क्या रहेंगे? They have to form, in the software the user has to form 0 to 9 counter with predetermined delay, convert the current count into digit drive pattern, put the current digit drive pattern into port for displaying. All these tasks are accomplished by the program itself. Then traffic light controller section here consists of 12 numbers, like 12 point LEDs. They are arranged by 4 lanes in 8051 development board. Each lane has green, which shows go signal, yellow to wait, and or you can say to get ready, and red to stop. They are being placed in such a manner as shown in figure. अब इसके अलावा बहुत सारी एप्लीकेशंस है, क्लोज लूप एप्लीकेशंस. क्लोज लूप मतलब जहाँ से किसी भी एप्लीकेशन से फीडबैक लेना ज़रूरी है और उसके तरीके से आगे के एक्शन को डिटरमाइन करना ज़रूरी है. सो दैट कैन बी डन using with the help of actuator and sensor, because sensor sense करेगा output end पर कि output proper हो रहा है या नहीं. If there is fluctuation in the output, it can be sensed and the actuator will correct it. Then these are some more examples. Heater के लिए भी same होता है. Then in our day to day life, mobile phones, the microwave ovens, then the sugar counting device, diabetes counting device. Then we have many applications like swiping the card, telecommunication, washing machine, USB drives. Then in every field there is automation these days. तो मेडिकल रहे या कोई भी फील्ड रहे, हर फील्ड में automation आ रहा है, and hence microcontrollers are used. These are some of the pictures that relate the use of microcontroller in day-to-day life. That's all for today's lecture. We'll discuss the difficulties in discussion session. Thank you very much.